Hello everyone, my name is Sebastian, and I'm the CTO and co-founder of dcSpark, a crypto ecosystem builder company. In this video, I want to talk about this concept that I think we can bring to Cardano called proxy contracts, which will improve usability of use cases such as multi-sig Plutus contracts, bridges such as the Milkumina bridge, but in general, any kind of layer 2 and sidechain bridge, and as well as DAO-based contracts as well. So the thing about Cardano is currently, imagine you want to send to a DAO contract. Well, you as the user, right, this is you, you'll have to send a transaction to the DAO contract. And in that transaction, you're not just sending ADA, but you're also adding datum. And this datum has to be formatted a specific way for the DAO contract to work properly. So that means that if you want to send to the DAO contract, you cannot generically do it from a wallet such as Flint or Nami or Eternal. You'll have to use a special dApp interface that knows how to create this datum with the right format. Now this is kind of okay because a lot of these DAOs, for example, will provide a website with a dApp connector experience to have this functionality work for you. This is, not always the best experience and may not even always be a choice. So for example, Catalyst is Cardano's treasury. And when you use Catalyst, you have to specify the address that receives the Catalyst funds if you get your proposal passed. And you can't be putting in your DAO contract inside this address field because Catalyst cannot send a regular transaction to this DAO contract. It has to be, again, a special transaction with this datum. And it's not reasonable to have the treasury figure out, which website to connect to get the right datum and the right format for all these specific applications. So it'd be better if instead of sending to the DAO contract directly, you instead send to a proxy. So you send to a proxy as a regular transaction with no datum, and then the proxy then sends to the DAO contract with the right datum. And if you do it this way, then you could specify the proxy contract as the address that receives Catalyst rewards. So why haven't we been able to do this before? So you might be thinking, oh, this sounds like a great idea. Why can't I do it right now? So the problem is that the way you would do this right now in Cardano is that this proxy contract down here would probably be a regular Cardano address or a multi-sig address, and it can't be a Plutus address because if the proxy was a Plutus contract, you'd have the same problem where basically you would need a datum again and then you can't send the proxy. So this proxy contract, this box right here, can't be Plutus. So you only have two choices. It can either be a multi-sig native script or it can be a regular Cardano address. But this is not great because the entire point of sending to the DAO contract was so that nobody can steal the funds, right? The DAO would need permission to spend the funds. So if you have to have an intermediate step with a trusted person or trusted multisig, this is not really great, right? You'd like to be able to basically provide this proxy, and this proxy has only one option, and the proxy has to send to the DAO contract, and there's no other way to do it. So that means to do this, we need some kind of way to build proxy contracts in Cardano without using Plutus. And the way that I'm proposing doing this is with a CIP I wrote that you can find right here in the CIP's repository for Cardano. And, oops, this is wrong. This one. Arbitrary scripts as native script spending conditions. So as I mentioned, in Cardano, there's actually two kinds of scripting languages. There's the Plutus scripts, and there's also this thing called native scripts, or something called simple scripts. These native scripts don't require the datum, okay? And so that's why you can send native scripts directly and not have to worry about this. The problem with native scripts is that they can't contain complex logic, right? So you would like to have some complex set of requirements saying, this proxy contract can only send to the DAO contract under these conditions, something, right? You want complex conditions to this, but but native scripts don't support complex conditions. In fact, they only support very basic stuff like multisig or time locks. So kind of like a Bitcoin script if you're familiar with that. And so what I'm proposing is allowing a new condition to native scripts. So this is the previous definition of a native script. A native script can either be spent if there's a certain key hash present. So this is how you do multisig. You could say you need multiple key, all of a set of keys, any of a set of keys, m of n set of keys, and then there's also the time lock feature. So this is what native scripts can do up until now. And what I'm proposing is to add a new case where you can say this native script can only be spent if a certain script also appears in the transaction input, right? And this would be the JSON notation where you could say that the native script only gets spent if a specific script is contained inside the input of this transaction. And what it essentially allows you to do is that you would have, like in our picture below, this proxy over here is a native script contract, and it comes with a script condition where it says that the proxy can only be spent if at the same time there is another script that's kind of like a forwarding script. So if you want to spend from the proxy, you need to not only use this proxy contract. You need to not only use this proxy contract, but you also need to include the forwarding contract as part of the input. And this forwarding contract can be a Pluto script, right? So the proxy cannot be a Pluto script. The proxy is a native script because it receives inputs from the user directly. And the proxy contract inside it says that the proxy can only be spent if you also have this forwarding script as part of the input. And inside this forwarding script is you say this forwarding script can only be used if the output contains the DAO contract. Or you could have more complex conditions. You could say like the forwarding script can only be used if you have a specific NFT or a specific time has passed or any kind of other condition. Or in the case of the Milkomeda bridge, you could say you can only forward if the ADA is going to the Milkomeda bridge wrapped to this specific address. So it sends to the Milkomeda to a specific destination address. So this is basically the idea. And to do this, we need a change to the Cardano protocol to basically add this new field to native scripts, which is just the required signers. And as you can see, this is a fairly simple change. So this is not like a complex change that requires a whole change of Cardano. A fairly simple addition to this language will allow for these proxy contracts. Now, there's actually a second problem that I haven't talked to you about yet that makes that even if we have these proxy contracts doable, it still is not a great user experience. And that comes with the way that Cardano addresses work currently. So currently in Cardano, when you look at an address of a smart contract, I don't think I have an example, maybe I should have prepared one. But if you look at a smart contract on Cardano, let me just write it out. Usually the smart contract address will look something like this. You'll have an address, 1, and then you'll have a script hash, and then a checksum, okay? And the script hash will be kind of any letter, some random thing. But the important thing is that this address is automatically generated from the script. So every Pluto script gets hashed and has a unique address on chain that represents this Pluto script. Okay? But actually, it's not just Pluto scripts that work this way. It's actually native scripts also work this way. So the native scripts also get hashed to an address. That means that just by looking at a script address on Cardano, there's no way to know if the script address was generated from a Pluto script or if it was generated from a native script. And the reason that this is actually problematic is because if you try and use a wallet like Flint, Eternal, Nami, and you specify for example, sending to a DAO contract or sending to like a multisig plus contract or anything like that, it will give you a warning or an error inside the send page saying don't send directly to a Plutus script, because again, as mentioned before, you're missing the datum, right? Your wallet, for example, Flint, will not be able to automatically know what kind of datum needs to be added. So you can't send directly from the wallet. You instead have to go to their website and use the dApp connector, right? So to avoid user error, wallets will warn you if you try and send to a Plutus contract. And that means because wallets cannot differentiate between the Plutus script and the native script, wallets will also warn you if you send to a native script. This is not a great user experience because we want users to feel safe sending to a proxy contract, which is a native script, knowing that this proxy contract will then be paired with a forwarding contract to send it to the DAO. And so to be able to allow for this, we need some way for wallets to differentiate between Plutus scripts and native scripts. And I have a SIP that I created for this also that I call script language annotated addresses, which is an extension to the address format on Cardano to basically add the script namespace as part of the address. Now, the nice thing about this SIP is that there's two ways to do it. One of them is to do it with an actual change to the Cardano protocol, which I call the on-chain version. And we can actually do the exact same CIP as an off-chain encoding. That's just a wallet level change. And the protocol itself doesn't even need to know that this standard exists, which means that this specific CIP does not require a hard fork to implement. It can be implemented purely at the wallet level. If you implement it purely at the wallet level, there'll be kind of some weird things, which is if you look at your wallet in your blockchain explorer, the address will be different. So it's not the most intuitive user experience, but still this will help a lot in making proxy contracts more usable. And so these two CIPs together will basically allow you to have, proxy contracts in Cardano, which will enable, cool use cases like sending Catalyst rewards directly to a DAO, or to be able to send Catalyst rewards directly to your Milkumida address or your L2 address, your sidechain address, directly from somewhere else, and just have that proxied through. Now, one thing that you might be wondering as I'm talking about this is, well, this sounds expensive. What is the gas cost of doing all of this? And actually, the gas cost is not that low, not that high, not as high as you'd expect. And the reason why is because there's no such thing as deploying a smart contract on Cardano. So if you're used to Ethereum, you're probably used to the idea of you deploy a contract to Ethereum and you pay gas to deploy a contract to Ethereum. And so looking here, you might be saying, oh, well, there's two contracts, so I have to deploy two contracts to the chain. And actually, that's not the case, because in Cardano, the contracts implicitly exist and don't have to be uploaded. And this is a benefit of the UTXO model used by Cardano. And so basically what you do is, imagine a user wants to interact with a proxy contract. What you would do from a developer perspective, if you want to create your own proxy contract, is you look at the user. The user wants to send to this specific DAO contract, right? So you take this DAO contract and you create a Plutus contract based off a template, where basically you add this DAO contract address into the template. You take this Plutus script you generate from the template, hash it, put the hash into the proxy contract as one of the required scripts, and then the user sends to this proxy address. So it's not like everybody shares one proxy address. Every user will get their own proxy address, or every use case will get their own proxy address, which embeds a script that is used for the forwarding script. And then basically whenever they send to the proxy contract, the forwarding script can then be known by some off-chain method. And then whenever the forwarding actually happens, that's when you basically post the contract to the chain and say, this is what the forwarding script is, and here's how it matches the hashes. And this is relatively inexpensive. So the benefit of the system is that you can basically have different forwarding contracts for different use cases. if you can, you may be able to sometimes reuse the same forwarding contract, and this keeps the gas cost fairly low for this kind of novel solution. And so I think for the very little amount of change that this requires to Cardano and the amount of use cases this enables, just even on the bridge side to basically allow Cardano layer 2s and sidechains to have a better user onboarding experience, is definitely worth it in my opinion. So that's my quick presentation about proxy proxy contracts. If you want to find more, again, like I said, I submitted 2 CIPs on the topic. One of them is arbitrary scripts as native script pending conditions, and the other one is language annotate addresses. And I'll have links in the video description where you can also check these out. So thank you so much for your time.